Hey guys, this is Adhertan, and tonight we are going to play SHENZHEN. We will continue on our prospective career of software developers working for a hardware developer company somewhere in China. Uh, let's check our mail. In the last episode we finished the post generator, and we have some more emails in here from Space Adventures. Take an orbit a selfie, trip stars adjust 89,000 and 90,000 are what's R? Is it Moscow? So it's rubles. I have no idea how much ruble is. Anyway, the adventurer experiences experience the star and the earth as you have never seen them before. Enjoy the surprise and delight of true weightlessness. And of course, take pictures of yourself that nobody will soon forget. Did you know that there has never been a better time to take a trip into low Earth orbit? Demand is skyrocketing and prices are cheaper than ever. Now is the time to get in on this trend, which has been popularized by international superstar Cool Dad and many others. Tickets are going fast. Light up signs. It begins! I got us an incredible deal with major esports personality, the Solid Steel Gamer. Her team contracted us with the make light up signs that actually animate for fans. As long as we can keep the cost down, they're going to want tons of these to head up at matches. Looks simple, just a few states. Gee. Okay, let's get to it. So click 0 and click 1 are simple outputs connected to a display segments corresponding to clicking animation. During 0, then during 1 and during 2 are simple outputs connected to display segments corresponding to drinking animation. Control the display segments with fixed repeated signals as indicated in the verification tab. So, okay, let's do it. We will have to do those separately. So let's start with the click animation, or the clicks impulses, or whatever you wanna call it. Let's connect the control to it. This is a small one. So there are two ways how we could do this. So what we can do is we can start. So these two signals are always opposite to each other. So what we can do is we can write one, then negate, then write the second, then negate. So what we'll do is we will start by writing 100 into the accumulator, then moving the accumulator to P0, negating the accumulator, that's just this, then moving again the accumulator to P1, and then sleep for 1. So this will, we will just use this. The at sign means initialization and it's only executed once. Actually, we don't even need that. No, wait, we don't need that. We do not. When the accumulator is negated, it goes from 0 to 100, and when the accumulator is 100 and is negated, it goes back down to 0. So it starts at 0, so we turn it to 100, write 100 into the click 0, then negate it to 0, then change the accumulator again to 0, write it to click 1, then we sleep for a second. Now accumulator is 0, right? So we hop in. No, so we don't want to do that like that. We need... right, so we need this initialization instruction, right? So what happens, we start off with 100. Oh, the other way around. Move 100 into accumulator. Then we write the accumulator into click 0. Then we negate the accumulator and write it, so that's 0. Write it to click 1. Then and sleep for a second. Then we flip again. We write whatever is in the accumulator into the click 0, negate the accumulator and write it. Right, so this should work. Let's test it. And indeed, it does exactly what we wanted to do. We could probably do it the other way around without the initialization. If we first write this one and then we write this one, would it work? So we can save one more line of assembly? I think it should. Yeah, it does. Right. So we just instead what I did instead of starting with the click 0 and first starting at the value of 100, we instead start with click 1 because there we have there we started at 0 value. Now we move on to the other animation, which is slightly more complicated. I don't think this will be enough. I honestly don't think this will be enough. Sorry, I'm sorry. So we will need, even simply because we have 3 inputs and all of these controllers, they only have 2 outputs. Well, we can only use the P outputs because those are analog input outputs. The X one are like digital input outputs. We can't use those. So since all the controllers only have 2, we will need 2 controllers, right? One for the most complex state and 2 for the simple one. So what we're gonna do here is, because there is a cost in the terms of number of instruction. Let's put in a big one. I feel we will need a big one, and we will use the big one to. How can I connect this and I can actually, if I hold tab, I can do it like this, and then we use this one. Can I? No, I can't. So I guess P1. Oops. P1 could be like this. Yeah, that seems sensible. Oh, we could move this one here. No, we can't. Okay. So drink 2, because that one has. No, we could have. So if we start on a certain level. So to repeat the. Let's start with drink 1. That looks like the most complicated pattern. So there we sleep for 6. Then we change to 100. Then we sleep for 1. Then we change to 0. We sleep for 2. Change to 100. Sleep for 1. Sleep for 1. Change to 0. And then we wrap and sleep for 6 seconds. So this is what we need to do the first one. And now I can only fit one more, and I think we can more easily fit drink 0 because it also have the sleep 6. So here we can use the sleep 6 where we start. So at the beginning we start on level 1. Oh, actually, now that I'm thinking about it, we might actually do the output 2. That might actually be better for us, because then we sleep for 7 seconds, and at the point where the drink 2 is going down to 0, we will go up to 100 via P0. I will have to reconnect those. Then we sleep for 2 seconds, and then where P1 or the drink 1 is going up again, that's where we go down, and that's it. Then we stay down. Yeah, so we can use all these instructions. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ooh, we can actually fit this into a small controller. Can we not? Why not? Yeah, I thought we could. It's 10, right? Or is it 8? Oh, it's 8. It's 8. We can only have 8 instructions, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we can have 9 instructions only. So we have 1 instructions too many. And I don't see how we could make this any shorter. What I have to do though is I need to reconnect, because we implement actually drink 1 and drink 2 in here. So I need to reconnect those. So I guess we can do it like P0 then is, well, we said P0 is drink 2, so I will have to swap those and say we want it like this. So drink 1 is P0 and drink 2 is P1. So this is P0, this is P1, this is P0. And this one, well, unfortunately, there is no other way. That one is super simple. It's just we start at 100, then we sleep for 6 seconds, then we go to 0, then we sleep for 4 seconds. Move 0 to B0, then we sleep for 4 seconds, then we go back up to 100. But that's already wraps. So that's like 4 lines. 1, 2, 3, 4. We could totally fit them in here, but we don't have any means of converting the signals. Or do we? Well, it says sparks are not recommended, but we could use this one because this one is cheaper. I'm actually tempted to try that. Let's try it. If we can optimize this even. Well, no. First, let's check if this works. Yes, this works. She clicks like crazy and drinks lots of Red Bulls. Yay! So we used 18 lines of code, which is pretty good. Most people need more, so we are actually better than most. In the terms of cost, though, we were more expensive, and in the terms of power usage, we were, well, average, I would say. But I wonder if we could optimize if we reduce the cost and possibly power consumption by using this thing. Where is the documentation for it? Here it is. So this is the DX300, digital I/O expander. It basically can convert from digital to analog signal. So what we can do is, and there is basically a table that I have here next to me. Sorry. It says that if we write 100 on the input P2, then if we write 100 on X1, it will generate 100 on P2. So I can't fit it in here properly. How could I? Well, let's do it like this. Then this P2. Which one is P2? Which one is X? Which one is which? So I assume it goes from top, so we need to go to top. Right, so it's 100. So if we write 100 into it, it generates output on P2. It's basically a bit mask. And now what we can do here is, so we sleep 6, we can also write no, we won't fit in here. Are we? So we need to start by default by moving 100 to X1. That's our initialization. Actually, it is not our initialization. We have to do it every time. Pin is not connected. Right, X0, of course, X0. Then we sleep for 6, and then we move P0 to 100, and we move 0 to X1 to turn it off. Then we wait for 4 seconds. That's 1 to X0. Come on. So then we wait for all this time. Right. So we wait a second. Then another 2 seconds. Another second. And then we hop back to the beginning and turn it on again. So let's see if that works actually. Why can't I? Pin is not connected to P0. Alright, because cool, so that works, and that should push the value, right, so that pushes the cost down to 9. You can apparently build it even cheaper. We still use 16 lines of code, and we are using still the same amount of energy. Makes sense since we are executing the same amount of instructions. I am wondering if there's a way how to, alright, there is a way, and I see it. Right, but that would be screw it. I'm not going to waste more time on this task. There will be a way to use this one again, and I think we should basically to connect all the 3 and then write to all of the 3 inputs, and then we would have completely different code, possibly fewer instructions and better power usage. Haha, the end result looks great. I love the way it looks like the Solitaire gamer is really clicking the mouse button and drinking her soda. This is going to be huge. Bring out the Baron from Joe. The Baron von Schnapps is in the house, y'all. I was out drinking last night and met someone from the company that owns this brand. There's a drinking game they are promoting that's hella fun and off the rails. I made a deal to supply them with little personal scorekeepers they can give away at their events. Carl, wait, what's the game? What counts as a point? What would be a foul? Surely not individual drinks. Joe, I don't remember the actual rules. Haha. Okay, I guess he was too drunk to remember names. Ah, cool, we have a display. Drinking game scorekeeper. Point and foil are simple input connected to a button. Display is an X-bus display output corresponding to a numeric LCD screen. The counter should keep track of count, starting at 0, and ensure that the display is always showing the current value. When point is pushed, count should be incremented by 1. When foul is pushed, the count should be decremented by 2, but not below 0. So I'm gonna immediately go for the bigger one, because well, we can always go smaller, right? Connect the first and the second, and the second one, and let's use X3 for output. So, sorry. So what we're gonna do is we check if the point is pressed. So we check if P1 is equal to 100, and if it is, we increase the value in the accumulator by 1. Next, we check if the foul is 100, and if it is, then we decrement by 2. Okay, it's not decrement. What's the name of the instruction? I forgot. Sorry. It would be sub, I think. Yeah, it's sub 2. And then we check one again if test is less than 0. Test if accumulator is less than 0, and if it is, then we write 0 to the accumulator. This is to handle the condition that we can never go below 0. And finally, we move the value of the accumulator to X3. And that looks solid. Let's see. Oh, well, I forgot sleep. Looks good. And looks awesome. Cool, we did. We actually, yeah, we can reduce the cost. Because we actually needed fewer instructions than I thought we would need. So we can actually just cut this and add this to this controller. This goes away. This goes in here. And I guess we connect it like this. Plop. Plop. And plop. Okay. And now we need to actually adjust. So P0. This is now P. No, this remains P1. So only this one changed. So let's simulate. Okay, so we are okay in terms of cost. We could be better on power usage, and we could be slightly better. Apparently, we can be better on instruction code, but we could be better. How can we keep the same amount of instructions, but be better in terms of power usage? That actually is intriguing. I wonder if it has something to do with. I think it has something to do with this final comparison of decrementing the accumulator and then checking if it is or is not. If it is or it is not 0, if it's less than 0, and so that's the one additional check. I guess it has to be. Sorry. So I wonder if it would work like this. I have to check because I don't know. point. Let's go through the points. And now we are approaching. Right, now we are here. So we check that this one is enabled. Right, so this is how it works. Right, so we can optimize by executing the comparison by checking if the we can optimize by checking if the accumulator is equal to 0 only if we just decrement it by 2. So only then this branch is executed, and if this is false, then this instruction gets disabled and is skipped, otherwise it is executed. So we keep the same amount of instructions, but we execute one instruction less in many cases, and that should exactly, this brings our power consumption lower, 268. Possibly it could be optimized even better. Not sure how. So we are done. Yay! If you can't remember the rules of the game you were playing, how sure are you that you actually made the deal? Because they send us cakes with a variety of flavors. It's very tasty stuff. Come try some. It's already far too late for me, but you can still save yourselves. Heed my warning. Do not drink of the Baron for schnapps. By then, see you in the next life. SHENZHEN days, saying stuff better. Hey y'all, yell. Sometimes it's tough to represent how a word really sounds in text, huh? Take, for a totally random example, SHENZHEN. How do you say it? What's that ZH doing in there? Can you just ignore the H spell warning? You can. ZH is its own sounding warning. We don't have time to go into all the foibles of pinyin, the official romanization time of Mandarin Chinese, so let's just give us little shortcuts. Say SHENZHEN. Well, I already am saying SHENZHEN. You know, like you're talking to your best friend, Chen. And, well, then you are probably closer than you were before. How's that for confidence? Yada yada yada. I don't need pronunciation test. Rubbish audio thing. Well, this one is going to be fun. So let's do it. But let's do it in the next episode. Thank you so much for watching. I hope you enjoyed this one. If you did, please leave a like. And I hope to see you in the next episode. Bye bye.